Hi everyone, I'm Michael Holly and I present you the project Maroon, a work-in-progress project at the Institute of Human-Centered Computing at Graz University of Technology. We are working on an adaptive virtual laboratory environment for educator-driven web integration in cooperation with the Institute of Solid-State Physics. Teaching science, technology, engineering and mathematics is often challenging and time-consuming. In physics, differential equations are an essential factor for connecting theory with real-world phenomena. However, traditional teaching methods often struggle here. Virtual laboratories offer a powerful alternative. They combine multiple simulations, are easily accessible, and support collaborative remote learning. In this work, we present a virtual physics laboratory environment for web applications to allow educators an adaptive integration into their course websites. The modular design allows individualized integration into customized websites and gives flexibility to extend it with different learning scenarios. For the web integration, we use the virtual laboratory environment Maroon. It is an interactive virtual laboratory that allows students to explore various experiments and phenomena in an immersive and engaging way. It is implemented in Unity and supports different platforms with different levels of immersion, such as virtual reality or web-based applications. The learning activities and experiments are designed for active learning to involve students in the learning process. Once users enter the lab, this could be a physics lab, a chemistry lab, or a computer science lab, Maroon dynamically creates the main laboratory room for the selected lab type. The main laboratory room consists of different experiment stations and acts as a three-dimensional menu where the user can select one of the experiments by navigating to the specific station. Each experiment or activity can be started from an entry point that acts as a portal into the simulation room, where each experiment has a customized user interface, including virtual control elements to control experiment parameters and visualizations. Maroon extends the physics engine and builds a new layer on top of the engine. Each experiment is based on this layer and provides physical modifications and visualizations. The figure shows the web architecture and the communication between the Maroon application. Teachers can integrate the web version of the experiment into their custom websites and can start an experiment with their own defined parameters via a submit button. The WebGL receiver class provides an incoming data event, which makes it possible to handle parameters received from an external JavaScript function. The callback function triggers the calculation and visualization process. The transmitted JSON data contains parameter values. It allows teacher to customize the simulation background and object appearance. The figure on the right illustrates the connection between a 3D motion differential equation solver and the Maroon web build. The web build is loaded into a div container, which allows a modular structure that can be easily embedded into different web environments. This modular design allows educators to integrate the experiment seamlessly into other web platforms. The possibility of integrating optional web content offers teachers the opportunity to display additional information about the experiment and make the lessons even more attractive for the students. Three different simulations and visualizations to support the understanding of difficult concepts such as differential equations and vectors in 3D. The first experiment is a 3D motion simulation. Simulation demonstrates the concept of motion, power, work, and kinetic energy in 3 dimensions. The user can choose settings from predefined simulations via a drop-down menu or set their parameters. Students should learn to calculate the trajectory of an object given the forces and its initial conditions. The second experiment, cathode ray tube simulation, is based on the same principle. The cathode ray tube experiment illustrates the electric deflection of an electron beam, in which the electrons are accelerated towards a positively charged plate. And the third light ray simulation focuses on reflection and refraction. Based on vector algebra, it allows user to interact with different lenses and light sources. Maroon Web is an immersive, interactive platform designed to enhance physics learning by enabling students to explore complex topics. Its modular architecture allows flexible integration of simulations via external web content, making it easily adaptable to different teaching scenarios. Students can manipulate parameters, observe real-time changes to develop deeper conceptual understanding through dynamic visualization and 3D interactions. However, scalability can be limited by technical constraints such as browser performance and WebGL compatibility. Future development will focus on integrating assessment tools and tracking learning outcomes. This will enable data-driven evaluation of learning progress and help refine the platform for more effective and engaging educational use. Thank you for your attention, and I'm looking forward to discuss it with you in the poster session.